so much, Justin. I really appreciate the invitation to give this presentation. I'd like to acknowledge, before I get started, the National Science Foundation for funding the majority of this program. The program leverages tools that were funded through the NSF EarthCube program, specifically the CORDS capabilities, cloud-hosted real-time data services for the Geosciences. And then we leverage also data and capabilities that are provided through the EarthScope Consortium. And I would also like to acknowledge that I'm presenting this talk from Blacksburg, Virginia, on the Virginia Tech campus, where we cannot separate the history of colonialism, slavery, and the forced removal of the traditional custodians of this land, the Tutaló-Monacan people. I pay respect to the Tutaló-Monacan nations and the former enslaved people who lived in this area. So my talk today has 5 parts. I'm going to give a brief overview of the CODE-GEO program, the history of the program, as well as the curriculum, impact, and future directions. So we'll first go into what is this program? CODE-GEO, as Justin mentioned, is a coding camp. It's specifically for novices. The acronym stands for Collecting Observations for Encoding in the Geosciences. We have a website that's linked. The website address is there at the bottom of the screen, and I encourage you to go there. We've spent a bit of time working on that website, so there's quite a bit of information there. It's really designed for small groups of undergraduates with little or no coding experience, but they definitely need to be interested and like really wanting to learn. Here we have a few photographs of some students who participated in previous CODE-GEO versions. The first 2 images are actually in Hampton, Virginia. And then these are students from a version of CODE-GEO that happened during the pandemic. So this was a rare time where we weren't wearing masks when we were outside. So we've spent a lot of time making the program as stress-free as possible. Here's a nice photograph of some snacks that we incorporated this year based on student feedback. So we take a lot of breaks. There's quite a bit of time to learn new concepts, all compacted or compressed into a 1-week program. And again, there's a lot of intention on making it as stress-free as possible. A lot of jokes, a lot of laughter, a lot of patience, just lots of effort to make coding something that's new for these students as easy as possible, as stress-free as possible. The program not only helps these participants, but it does provide some teaching opportunities. Pictured here are 7 individuals who've been involved in either the kind of governance of the program, or they've taught in the program, or helped to keep it running. So I do lead it, but there's always a committee that's standing behind the program. So whenever I'm saying we, it's not just me. It is these individuals here that have helped out all along the way. So in the beginning, it was Professor Bill Moore and myself, with some support by Dr. Josh Jones. And then in later years, with the new funding scheme, which I'll talk about, these 5 individuals over here have supported the program. Dr. Emmanuel Njenju, who's currently a postdoc at UC Davis, but just signed the paperwork for starting at Baylor University. Also Rufus Hinton, Reza Jian-Najjar, Karen Williams, and Asenath Kwagalakwe. So these individuals who get to teach, so they are gaining experience in addition to the students who are part of CODE-GEO. This is Rufus over here teaching in the virtual version of the program. Asenath Kwagalakwe here teaching about how to set up campaign GNSS equipment. Here's Karen and Emmanuel teaching in our in-person version of the program during the pandemic. So lots of teaching opportunities in addition to gaining coding skills for the students who get to participate. In 2023, we actually had this surprise opportunity. I was contacted by University of Texas Austin's Strong program leader. That's a program for also underrepresented students in STEM. And the director of that program asked if Emmanuel and Karen would be interested in actually flying out and being paid to run the program themselves. So here's a photograph of Emmanuel and Karen at the CodeGEO Strong program at UT Austin. So that was a great experience for them as well, to get to run a whole program. And then we also were able to impact 8 undergraduate students and help them learn some new coding skills. So that's the basic overview of the program itself. So I'll tell you how it got started. So it began in 2018. It's the collaboration between Professor Bill Moore and myself. Bill visited Virginia Tech and asked me if I would be interested in doing some work in the Chesapeake Bay. He lives right on the coast of the Chesapeake Bay, and his neighborhood is impacted by land subsidence, and he wanted to start doing some measurements, GNSS measurements out there to better quantify vertical land motion in the region. So we came up with this idea that we would create a student-focused program where the students would go out and do the measurements. We initially got some seed funding from the Virginia Tech Institute for Critical Technology and Applied Sciences program called ICTAS. They did a nice feature about the program in a 2008 magazine. So this was the origin of the program. It ended up being quite a bit of driving on me. So we did half of the program at Virginia Tech and half of the program in Hampton. So these were the 4 students that were in the first iteration of CodeGEO. This is actually part of my lab space area. Over on the right here are screens where I'm monitoring a volcano in Tanzania. And then we set up like I configured the space so I could teach. So I'm standing in front, and then behind me is a screen. So all the lectures were in this room, and people had their own laptops, and it was a very kind of self-contained program at this point. And then we also drove down to Hampton and installed some benchmarks. So this photograph on the left here are 2 of the stations and 2 of the students and Josh Jones installing a benchmark on a rooftop. We installed 2 new rooftop benchmarks. And then this is a computer lab at Hampton University where the students are working together on their project. So the program involved collecting data as well as some analysis of existing data, and then putting together a team poster. So this is the poster from that original program. Everybody works on it together using Google Drawing. To create such a poster, they learned numerous technical skills like Google Draw. They were plotting and formatting data to be plotted with generic mapping tools. So that required them to learn how to use a terminal, a little bit of awk. We use the text editor VI. This map here, so they made this one over here, also this one right here, and this one. So they had to do a little bit of interpolation of existing data. They also provided some suggestions for future work. But lots of good things happening with this poster. In 2020, I got a grant from the National Science Foundation. Thank you very much. And this program was part of the education part of the career award that was funded. So it funded a CodeGEO iteration for 2021 through 2025 annually. So the scientific focus was revised to be on volcanic hazard assessment, specifically using GNSS observations that were the core of this particular NSF project. On the right here is a map of the volcano Odyonyolongai. This is in Tanzania. It's adjacent to this natron border fault here. And then the blue triangles are GNSS stations that stream data to the Earthscope consortium, specifically the Gauge facility, through the green lines, which are the communications network. We also have a seismometer here. That's the square at 0006. And then it's located here relative, this is where it is on Earth. So the data collection for the new iteration of CODE-GEO is through online sources like CORDS, again, cloud-hosted real-time data services for the Geosciences. That's one platform where we can get high-rate GNSS data, positioning data, and then so that's one source. So the 2021 version of CODE-GEO, unfortunately, that was right in the middle of the pandemic. So we were forced to make this version of the program virtual. We decided to do half days instead of full days because it's quite challenging to sit online for an entire day for 5 days. We had 6 people admitted in 3 different time zones, but unfortunately one of those people got COVID and actually couldn't participate. But we ended up recording everything and providing the recordings to all 6 participants. So we had a very strict schedule. It went from 8 a.m. to noon with 2 breaks, Monday through Friday. It was May 24th through 28th. And then we developed a virtual machine that everyone installed on their laptops so that we all were working from the same platform. And then we used Slack for most of the communication, in addition to a little bit of email, but tried to confine it all to Slack so that the students could learn a new tool and also stay in touch if they were interested in keeping in touch with one another in that platform. The 2021 participants also developed a poster. So this is that particular poster. Some skills that they learned. They developed scientific project ideas, including testable hypotheses. They downloaded real-time positioning data with a shell script and plotted that data with generic mapping tools. They did some very simple statistical analyses. And then over here on the right, there was interpreting of those results and then figuring out some reasonable next steps. In 2022, we bravely did an in-person program. We did lots of masking. So we ended up with 4 participants, 3 from Virginia Tech and 1 from Hampton University. And these are the students from the 2022 CODE-GEO program. This program was from 8 a.m. to 5 p.m. Monday through Friday. We had lots of breaks and they had really long lunches. Also took them out for dinner on the Friday of the program. And this time we had the option to use a computer lab at Virginia Tech in the Department of Geosciences. So we did that. So everyone again had the same environment to work with. And then we also use Slack for most communication. For the in-person version of the program, we have actual presentations. So this is a screenshot of their first slide and then giving the presentation in that computer lab and the photograph here to the right. And then they also did a poster as well. So this is the poster from the 2022 program. Here we have, again, scientific project design with testable hypotheses. Similar to the previous version, that they downloaded real-time positioning data using shell scripting, and then they also plotted data with generic mapping tools. This black image here in the back under methodology, that's a screenshot from the capabilities you can use with CORDS. For this in-person program, we also incorporated Python in Jupyter notebooks. So these plots here are from plotting that high rate GNSS data with Python in a Jupyter notebook. And then they also did some very simple statistical analyses and came up with some next steps or further research. 2023, this time we decided to do another virtual iteration of the program, still half days. These are the 4 participants from 2023. They were from all over. So we had 1 student from Hampton University, 1 student from University of California, Berkeley, a student from University of Wisconsin-Madison, and a student from Bowdoin College. Again, everyone used virtual machines this time, and then Slack for most communication. We had, again, a poster. So here the students investigated height variations at 2 GNSS stations. They learned similar skills from before. This time we did not have time for the Python. So, but we did do scientific project design, testable hypotheses development, some simple statistical analyses and plotting with GMT, real-time positioning data, downloading. And then just recently, in early March, we did our 2024 version of the program. We had 5 students who are pictured here on the right. 4 students are from Virginia Tech, and then 1 student was from Riverside City College in California. This one was from 8:30 a.m. to 5 p.m. Monday through Friday, again with lots of breaks and long lunches. Also, we went out for dinner and ice cream Friday night, which was quite fun. And this time we had our computer lab and still Slack for communication. So these are the students in the bottom right giving their in-person presentation, and then a screenshot from their slides here. This version of the program also had a poster, which is pictured here, and we decided to focus on some numerical modeling this year, in addition to plotting with GMT, some shell scripting, a little bit of awk. But we incorporated this time some numerical modeling with the CODE-GEO models because we actually had velocities this year. We had some nice solutions from our network that the students could leverage to develop some testable hypotheses. So here in the middle, we have some actual numerical modeling results. And then they were able to learn statistical analyses with the F-ratio test because that's incorporated into D models with this version of the program. So that is the history of CODE-GEO. Now I'm going to give you an overview of the curriculum that is implemented. For the virtual CODE-GEO program, the days are structured in this way. So days 1 through 5, which is Monday through Friday. For technical and teamwork lessons, on day 1, we cover the Linux terminal, VI or the Vim text editor. Day 2, it's awk and shell scripting. Potentially, arguably, these tips for digital organization and time management could be considered technical. Day 3, generic mapping tools, an overview of the TZ Volcano project and network, shell scripting to obtain data. And then day 4, some more shell scripting and data analysis. And then day 5, they work on their poster, learn some tips for using Google Draw. There are also these cultural effectiveness and professional development lessons incorporated throughout the program, which the participants have really said they appreciate. So we do active listening skills on day 1, tips for digital organization and time management, how to interrupt implicit bias in the workplace, what is intercultural competence, and then we spend time on LinkedIn accounts so that they have a nice professional presence on the internet. for future career development. The curriculum for the in-person 2022 program is shown here. So quite a bit more content because we have full days. Technical and teamwork lessons are shown here. So again, very similar topics, but this time we did incorporate programming and plotting in Python on day 2. And we also added on day 3 an introduction to volcanology. We had GNSS instruments in person. So we actually took the students outside and showed them how to properly set up a campaign GNSS station and talk to them about the different pieces of a GNSS instrument. So those were some differences. And then cultural effectiveness and professional development are highlighted here. Again, on day 1, we do active listening skills, and those are propagated throughout all of the afternoon sessions on cultural effectiveness. So how to interrupt implicit bias in the workplace. The students also use active listening skills, active bystander training as well here. For a LinkedIn account review and setup. Those are working sessions, and then intercultural competence. Active listening is used there as well, also for the inclusive behavior here. One of our some in-person activities during this version, we had a graduate school panel. We had the chair come in, or the head of our department come in and give a brief talk. And then a really fun activity we have is the Museum of Geosciences tour as well. And then finally, for the 2024 program, I'll walk you through the curriculum. So we modified it a bit for this version. So technical and teamwork lessons. On day 1, we had the Linux terminal, Vim, volcanology introduction, and awk. On day 2, we did shell scripting, the TZ volcano introduction, scientific method, generic mapping tools. Day 3, we introduced the students to D models, experiment design, lots of practice with D models and the GNSS instruments. Day 4, we did F-test statistics, project development, dynamic presentations, some tutorials. And then day 5, we limited it to the grad school panel for the technical part on Friday. And then for cultural effectiveness and professional development, day 1, active listening skills, implicit bias on day 2, Google Scholar tutorial on day 3, as well as active bystander training. We did LinkedIn accounts on day 4, intercultural competence. And then on Friday, the inclusive behavior was our main cultural effectiveness there. So a little bit about the cultural effectiveness lessons. Virginia Tech has these really nice short videos that are instructional about topics related to cultural effectiveness. They're called Inclusive VT Insights. So we leverage those videos because they are experts giving information about sometimes challenging topics. So this is an example screenshot from one of those websites on how do I interrupt implicit bias in the workplace. And it's by Anita Genius. She's the director of affirmative action at our university. So there's these, this was a bit of a longer one. It's about 9 minutes. All the other ones are a little bit shorter, but we generally watch one of these videos and then the instructors rotate facilitating a discussion that includes leveraging the active listening skills learned on day 1. For the technical lessons, they are generally a mix of lecture material and then real-time coding. All the technical lessons, including the cultural effectiveness lessons, are shared with the participants via Slack. So this is a screenshot here on the right from our 2024 program. So you can see I'm linking up here the Linux tutorial, the VI cheat sheet, the VI tutorial, the awk tutorial, so the volcanology lesson, and then at some point there was some mention of Vasquez rocks, so I gave them a little link about that. And then also shown here is a day one exit survey. So we do an exit survey every day. It's a very simple one, like what did we do well? What could we do better? You know, what's something that you learned, to help give us some quick feedback. That's actually how we incorporated snacks. Someone mentioned we should have snacks. Okay, so a little bit on impact. In 2023, I reached out to all of the alumni and I just asked two questions. What are you up to now, educationally or career-wise? And then how was CodeGEO beneficial to your current educational or career path? So all the participants that responded, which wasn't all of them, but all the ones that did, indicated that they remained in STEM fields. So either they were in industry in some STEM related field, or they could have still been in undergraduate, looking for grad programs, or maybe they were getting into grad program. There was one alumni who earned an NSF Graduate Research Fellowship, so that's really exciting. One alumni is professionally managing GNSS networks now. Several alumni are conducting undergraduate research in geophysics. And then I also went through and checked out the LinkedIn accounts for alumni, and it supports that all of the previous alumni that I could find all the information for have remained in STEM fields. So I'm happy, definitely happy about that impact. And then with respect to the second question, of the responses I received, I'm just going to go through some of them. CodeGEO has helped me get into the world of coding and encouraged me to incorporate coding into my everyday research. Also, CodeGEO has helped me become a more advanced scientist, as coding is a necessity to science. And so I will emphasize that, you know, we only admit students who have very little or no coding experience, because we're really trying to give these students a leg up, you know, kind of open doors that maybe wouldn't be open to them otherwise. So another student said, CodeGEO has greatly helped me with my geology classes and other research opportunities I've been a part of. The program gave me the necessary skills to succeed academically and professionally in the science community. It will certainly help me with future research, as I am hoping to work on planetary geology with lunar stimulants and analogs. Another person said, I'm extremely grateful for the CodeGEO, which improved my comfort with computer science. I became more comfortable problem solving and accessing the widely available tools for geosciences. And then I'll show one last one. The skill sets I learned in CodeGEO were transferable and have been beneficial to my current position. I've been able to utilize and enhance my understanding of coding and use various techniques to analyze and interpret data for our company. The rigor and training of the program hugely shaped my career path, and I'm very appreciative of that. And then a little bit by the numbers. So far, since 2018, there have been 22 alumni from the main CodeGEO program. With respect to preferred pronouns, one alumni uses she, they, 14 use she, her, and 7 he, him. And then by the numbers, 95% of participants from the main CodeGEO program are from groups that are considered underrepresented in STEM. And then we also had this additional program at UT Austin where there were eight alumni, but we didn't have applications, so I can't really speak to exactly like preferred pronouns or their whether or not they're really from underrepresented groups in STEM. Okay, so last part of my talk is on future directions. So I do have a few future directions planned. The program is definitely funded through 2025. So we'll be having another iteration of the program in 2025. We're still deciding if we want to do it virtual or in person. It's certainly really fun to do it in person, but there's advantages to virtual in that you can get people participating who may not be able to make the trip in person. And, you know, for example, like we had 90 applications this year and we only had money to bring in one person who wasn't at Virginia Tech. Because the CODE-GEO participants generally get some kind of stipend for participation and supporting the travel as well as the stipend. And it's a bit pricey for what we have budgeted. So beyond 2025, I am definitely seeking new funding streams to continue the CodeGEO program. What that looks like is still to be determined. And then I'm planning to make lessons open access and easy to use. So if anyone else wants to run a similar program, they could have the lessons and implement it themselves as well. So this is the end of my presentation. Thank you very much for attending. I really appreciate it. And I'm happy to take questions.
Wonderful. That's really an inspiring program that you guys have put together there. I appreciate you walking us through kind of the history and showing us some of the participants and how that's impacted their journey as well. So that's great. I've got a ton of questions on my side because I'm very curious about this, but I guess maybe I'll just take this opportunity to encourage anybody tuning in from our live audience. If you do have a question for Sarah, please feel free to go ahead and type that into the Q&A box and send those in. And until some of those start arriving, maybe I can choose from among my list of questions. I guess the first one that comes to mind for me, Sarah, is you talked a bit about the alumni survey that you did and some of the results of that. And it was really impressive to see that it seemed like all of the students were still engaged in some sort of STEM related endeavor, which is amazing. I'm curious to know, like, are there other ways in which you also evaluate the program? I'm thinking of things like pre and post course surveys to measure learning against, you know, like your goals or things like that. And, could you say a bit more about any other types of evaluations you might have done?
I mentioned there are daily exit surveys, and then we
Yeah.
also do a final survey, like at the end of the program to gather feedback. But
Okay.
at this time, there's no like professional evaluation, maybe of like material learned, which I think is something that I could work into like a new proposal for like future funding of the program. That's definitely one area that I think we can improve on is being able to do some more effective surveying of the impact of the program.
Yeah. Yeah, no, and thanks for reminding me about the daily surveys because when you said that, I made sure to write that down next to this question here because I think that's great, and I'm sure that you probably it sounds like you were able to get and utilize some useful feedback from that as well in terms of making the students comfortable and bringing in snacks and things like that to help make it a more enjoyable experience for everybody. So that's great. Um, we have had a few questions come in, so maybe we can start with this one from Thomas that asks, do you have any thoughts on doing a hybrid course in 2025?
We have discussed hybrid and kind of we decided not to do hybrid. Like hybrid was an option for 2024. And we ended up deciding no because there's so much interaction that happens just face to face. And we didn't want to detract from the experience of people that were in person. But you know, we're probably going to have that conversation again and maybe decide that hybrid would be doable. I'm personally a lot more comfortable now with hybrid settings. So that, you know, we may consider that. Thanks so much, Tom, for that question.
Maybe if I might tack on to Tom's question here about
Mm-hmm.
the format of the course, that was something that I thought was interesting too. And I guess I'm wondering how how offering it in the different formats, virtual versus in person, how that impacted the program in a number of ways. I'm thinking one, like accessibility. Were you able to bring in either more students or a more geographically diverse range of students for virtual, because you don't have like travel considerations and things like that, or were there other ways in which kind of the makeup of the group was impacted by the format of the program?
For sure, the format of the program definitely impacts how the makeup of the group. So when we do it in person, I mentioned that there's generally funding for just one external person to participate because we pay for the housing, we pay for the food, um, try to pay for all of the flights. Um, and so that, that adds up because the budget at this point is quite low. Maybe I could ask for more money, if I write a strong enough proposal, maybe we can alleviate that issue. And then the virtual setting. So anyway, so the in person, it's usually like at least 3 or 4 students from Virginia Tech, and then one external person.
Okay.
And then the 2 times that we did it virtually, it was quite diverse as far as geographic scope. Um, and I believe I know that one year we had 0 people from Virginia Tech. It was all external to Virginia
Oh,
Tech for
wow.
the virtual program.
Okay.
Yeah.
Interesting.
Um,
Great, great. A
mhm.
few other questions here. One from a familiar name here from Leah April. She asks, are there any programs that you would recommend for new graduate students in a geo-related field that want to get a good introduction to coding?
I believe I believe there's a few programs or one program through Earthscope. I could be wrong. I think there's a seismology MOOC or something. And
Yeah,
then
I mean,
yeah, go ahead.
I was just going to say that. So, coding is one of the topics that's covered with the seismology skills building workshop that Earthscope
Yes,
offers
yes.
during
Hmm.
during the summer, and I know that program has really grown in terms of the interest and number of people that have participated. So, I think there are ongoing efforts to try and expand the number of topics and whatnot that covers. So perhaps that would be a good resource, and it may have more coding content in the future.
And then yeah, beyond the seismology skills building workshop, um, I'm a certified carpentries instructor, and then Karen Williams and Emmanuel Jinju are also certified carpentries instructors. So we um, use that knowledge to teach coding and more effectively. Like when we're vocalizing the details of what needs to be like typed into the command window, for example. The carpentries has some suggested skills, like say the space, like say whatever, like say if there's a space, say it, as like a small thing. Um, so I know that the carpentries also has a lot of free online lessons that can be used. They have really nice shell, like how to use the terminal environment. So I would also point people towards the carpentries lessons.
Excellent. A question here from Donna who asks, she says, nice talk, Sarah. Could you say more about your strategies for teaching the technical components of the course? For instance, did you provide example scripts that they modified, things like that?
Yes. When it comes to teaching the terminal, like just basic knowledge of how to use the terminal, I create an example.txt file that has some funny information in it, and then also like a section of text and then a section of numbers at the bottom. And so we use that example.txt file in a number of little exercises. So that gets people going, and we're able to use that same little text file for awk, VI, like shell scripting. Like I build like a bunch of lessons around just using this one simple file that has both text and numbers and then a bunch of spaces so we can so they can build their knowledge off of something they're used to. Um, so I mentioned there's like a mix of slides. So the slides are formatted in a way that like things that they're supposed to type in the terminal may have like one color. And then if there's an exercise for practice, that may be like in bold or a different color. So I'll use different like code, like different text fonts on slides to help the students visualize like what's next. But then there's also the instructors, like we're always behind the slides, like talking through what to do. And then again, there's like 2 or 3 of us at all times in the room. So there's really good contact between, not physical contact, but like verbal contact and like being able to support the students as questions come up. There are, usually it's not that I provide an example script that they modify, but we may, at one point, like this past year, plotting the velocities, I did put up like line by line after we went through a GMT tutorial. We would go line by line through an existing script that I wrote. Yeah, so it wasn't exactly that I was giving them a script, but they were developing the script themselves, and we would kind of walk through what was happening as they typed out the script.
Excellent. Another question here from Thomas. It says, how problematic is it for students to convert ideas of what they want to do to code that it will do? Like they want the largest value in a list, how to do that in a code. I don't know if you could maybe respond to that question.
Okay, how problem is it for students to convert ideas of what they want to do, kind of like to what it will do?
So maybe going from like an
I don't know.
idea to
Yeah,
actually coding it up.
I'll say that something that was just kind of I noticed was an aha moment for students was when we had them like put 2 terminals up side by side, and like they edit a program in one terminal, save it, and then run it in the other terminal, and they could see the change that they made like pop up or like in the other terminal. And like they were like, I don't know, it seemed like that was a really big clicking point for people. Like they make a change over here and then they run it over here and they're like, oh, I see, like I'm actually coding and this is what happens, this is what changes. So I think that was maybe close to what you're asking, Tom. And that was really like day 4, I think, when things really started to click. And it was a bit challenging this year because we were switching platforms a bit because D models runs in MATLAB. And so you could do a lot of things in the MATLAB environment. But then if you want to like maybe do some kind of detailed analysis, or it was mostly plotting that we did with GMT this year in the Linux environment. It was a little bit challenging this year switching back and forth between those platforms, but I don't know, I hope that answers your question a little bit.
Maybe looks like a question here from Anne asking, do you plan to include AI tools in the program moving forward?
I think that's a possibility because in my research group, we have been using Jupyter notebooks to explore machine learning clustering algorithms on that real-time like high rate data that we extract from CORDs, which is essentially coming from Gauge. So there is the possibility we could do that. Like we have kind of the foundation for building lessons around at least not necessarily AI, but at least machine learning clustering tools. So that's a possibility. That is definitely a possibility.
I wonder if, Sarah, if maybe you could say a little bit about when thinking about the course content here. You showed us some agendas for the weeks and how they kind of varied from year to year. How did you how did you make those decisions about what to change or when to, on what day you were going to teach a particular topic or in what order or that kind of thing? Maybe you could speak a little bit about how that worked.
Yeah, it's always by committee. So I've mentioned it's never just me. There's always like 2, it's usually 3 of, in the past few years, it's been at least 3 of us. So there'll be 2 to 3 other people besides me who are part of the planning and implementation of the program. So we start planning months in advance. And then as the time gets closer, we'll put together a big spreadsheet of the schedule and how long we're going to teach what and what needs to be taught in what order and who's going to teach which parts. Um, so it's really decided between the people who are teaching that year. So this year it was Karen, Asenath, and myself. Um, you know, several months before and leading up to it, we were just discussing what we wanted the students to learn, what we wanted to adopt from previous years. Eventually this year we came to the decision that we wanted to try D models this year. So that changed quite a bit. You know, there were things we didn't have time for that we did last year. Um, so it's really iterative process, I could say,
Mhm.
with a discussion between multiple people who are going to be teaching the program.
What about just the schedule in general in terms of when during the year you host the event? Is there a typical time every year that it tends to happen, or how does that get decided?
In the first couple of years, given that it was started as a collaboration between Hampton University and Virginia Tech, we aligned it with Hampton University's spring break. So that was really the deciding factor.
Mhm.
And then this year, we also were doing it in that way, hoping that we would get students from Hampton University, but it turns out we didn't have any students from Hampton University apply. So we switched it to the Virginia Tech spring break. And that actually worked out really well for all the students that were accepted into the program and who were able to attend. So it centers mostly around spring breaks, I could say that.
Okay.
Whether or not it's a specific university spring break or Virginia Tech spring break, that's how we're doing it.
Excellent. Great. Well, I think we've made it through all of the questions that have been submitted. So maybe we'll wrap things up here, but just want to take a moment again to thank Sarah so much for sharing her experience and the background and all the excellent work that's been going on in the CodeGEO program. It seems like it's a really exciting effort that's having a good impact on the next generation of geoscientists. So excellent
And
work. And oh yeah, go ahead.
I did want to make one more comment. I meant to say, if anyone is interested in the lessons, feel free to reach out to me and I'd be happy to share them. And I could talk you through kind of how to use them. So there, I do need to, my number 3 there is to make them open access and easy to use. At this point, there would be a little bit of instruction needed for someone just to pick them up and use them, but I'm happy to talk to anyone that might want to run a program like this.